Just say this again for those that are at home. We forgot to start recording. Deductive reasoning is making conclusions based on statements. Inductive reasoning, making conclusions based on patterns you observe. The patterns, at a very young age, you start noticing. You see people do things over and over again, and you realize what's going to happen. We said lawyers use deductive reasoning to put together arguments to try to prove their case. And now we're moving on to law of detachment. And that can be read, if P implies Q is true, then given P, you can conclude Q. Or you can read it, if P then Q is true, then given P, you can conclude Q. The key here is P is what part of this statement? What part of the statement is P? The hypothesis. And so we're saying if this statement is true, then when we're given the hypothesis, we can conclude the conclusion is going to happen. Okay? I was picking on Troy the other day in class, saying his mom said if he did his homework, then he could go to the movies. I think I asked you the same question, right? And then I said, if we see him at the movies, does that mean he did his homework? No, it doesn't. It doesn't mean that. The only way we can make a conclusion is if we know he did his homework. The statement was, if you do your homework, then you can go to the movies. The conclusion can be made, if we know he did his homework, we can conclude he's going to the movies. Right? That's the only way you can make a conclusion, and that's the law of detachment. Law of syllogism is a little more involved. Law of syllogism says if P implies Q and Q implies R are true statements, then given P we can conclude R. Alright, the key here, you're going to get statements that are kind of wordy and they're confusing, and what you'll want to do is to identify them in terms of P's and Q's and R's. Okay? Which of those three letters is repeated? The Q. So when you're reading these complicated, confusing looking statements, identify which part of each statement is the same, and you're going to make that Q. And notice that when Q is the second part of the statement, what's the first part? And when Q is the first part of the statement, what's the second part? R. I didn't repeat that. Maybe it didn't pick it up. But when Q was the second part, P was the first part. And when Q was the first part, R was the second part. And then we could take those confusing statements and we could rewrite it as P implies Q. We can rewrite them that way. And then if we're given P as a true statement, we can conclude Q is going to happen. We're going to practice a couple of these to give you a better idea of what we're talking about. But the only way you're really going to get it is to get into the homework on these and struggle with them. Because those statements sometimes will be given to you in a nice, neat order, and sometimes they're going to be flipped around and they're not such a nice, neat order. So the way to really get it straight is to relabel them with P's, Q's, and R's, and understand the statement that repeats we're going to want to call Q, and then call P and R whatever is, depending on which one you're looking at. Is Q second or is Q first? Okay? Any questions so far on this? I know you don't totally get it yet. You won't until we look at some. Okay, moving on then. I'm going to pause this and let you copy it down. Oh, actually, I didn't need that on here. Copy these down, and then we'll talk about, there's a third statement here. I'll have to move it up in just a second. See, we had a little typo here. It was Canis Rufus, not Can is Rufus. Here's the rest of it, the third statement. All right. We're just going to look at these first two statements here to begin with. It says if an animal is a red wolf, then its scientific name is Canis rufus. The second one says if an animal is named Canis rufus, then it is endangered. So we have two statements there. They're both conditionals. What's the hypothesis of the first one? An animal is a red wolf. What's the conclusion of the first one? Its scientific name is Canis rufus. Good. What's the hypothesis of the second statement? And the conclusion? Okay, so there's really only three parts there, isn't there? Which part is repeated? Okay, so the part that's being repeated is the Canis rufus part, right? So that's what we're going to call Q. Having a scientific name of Canis rufus is what's being repeated. Okay, so when Q was second, what letter went first? P. And when Q was first, what letter went second? R. And so we have if P then Q, if Q then R, so we can conclude, we can conclude if P then R. Okay? So Johnny has a red wolf for a pet. Well, which is that? Is that P, Q, or R, or nothing? Johnny has a red wolf for a pet. What's that? That's a king of rye, quit watering. Guys, I need to be talking about this. Which part is, I'll give you a hint, it's one of them. P. So Johnny has a red wolf for a pet. Is that P, Q, or R? P. That's P. And so if we are given P, then we can conclude what? R. So what's our conclusion? What's R? No?
It's endangered.
It's endangered. What is endangered?
Which is also the Canis rufus.
Okay, but more specific to this statement, what's endangered? Johnny's pet. So we say, our conclusion is, Johnny's pet is endangered. Oops, there. Johnny's pet is endangered. That's going to be our conclusion. Okay? So you want to write it in terms of P's and Q's so you can keep this straight. Then it's a simple follow the rule. Okay? It's a simple follow the rule. If you set it up P then Q, Q then R, then we can conclude if P then R. So if they give us P as a third statement, we can conclude R, the final statement. In this case, R was being endangered. And so then to be more specific to this question, what's being endangered? Well, Johnny's pet. Johnny's pet is endangered because he has a red wolf, and red wolves are endangered. Okay? I don't remember what I wrote here. Oh, that is this statement right here. This, if P then R, that's how you'd write that. If an animal is a red wolf, then it is endangered. And so we're looking at Johnny has a red wolf for a pet, so that means Johnny's pet is endangered. All right? You don't necessarily have to rewrite this down here. Let's move on. I don't know if you can read that. There's too many symbols in there. I didn't want to take time to clean that up. It says, if n is a prime number greater than 2, then n squared is odd. And then it says 9 squared, it almost looks like a cube, but it says 9 squared is odd. Okay, I'm going to pause so you can copy that down. Okay, again, if we identify P's and Q's here, we only have two statements. This says if n is a prime number greater than 2, then n squared is odd. What's the hypothesis there? Okay, so this is P, our hypothesis, right? And so if that's P, what's Q? N squared is odd. Okay? So looking at that now, what is this? Yeah, it's Q, isn't it? Okay? So this is not, I don't have a Q then R, do I? Okay? So this is not a law of syllogism like we just did. This would be law of detachment. What's law of detachment say? If we know this is true, then given P, we conclude Q, right? Okay, this is a true statement right here. If n is a prime number greater than 2, pick a prime number greater than 2. 5. What's 5 squared? 25. That's not a number, isn't it? Pick another prime number greater than 2. 3. 3 squared is 9. Is 9 odd? Yeah. Pick another one. 7. 6 is not prime. 13. 11. 17. 19. All those prime numbers. When you square them, you get an odd number. Okay? So that first statement is true. Does this information match this? Are we given P? We're given P here in this statement, but are we given P in this next statement? No, what are we given? What are they trying to get us to say? Remember, we've talked about this already, another situation where we have to be aware of the converse. They're trying to get us to say that 9 is a prime number greater than 2. Is it? No. Okay? It's not. And on top of that, even if it was, that's not a conclusion we can make based on this. Okay? If we're not given P, then we can't make a conclusion. So our answer to this would be no conclusion can be made. Or you might say, not enough what? Said this the other day. Not enough info. Need more information to make a conclusion based on that. Okay? So you have to be careful when you're applying the law of detachment that you don't let them suck you into giving you the conclusion instead of the hypothesis, and then you try to make the converse a true statement. Okay? The converse might be true, but we don't have enough information to know that for sure. Right? Any questions on this? Not everything they give you is going to be true, so you have to be careful. Okay, that's it for today. Let me pause a second. I'll tell you what your assignment is.